Start. Hello everyone, today let us see the PN junction diode. That is, first let us see the formation of PN junction diode. Okay. Now, let us see what is a PN junction. A PN junction is the basic building block of many semiconductor devices like diodes, transistors, etc. Let us consider a thin p-type silicon semiconductor wafer. By adding precisely a small quantity of pentavelent impurity, part of the p-silicon wafer can be converted into n-silicon. What does it mean? Simply we cannot bring p-type semiconductor and n-type semiconductor and join them together with glue, gum or fevicol. It doesn't work. There is a chemical process for that. What is that chemical process? There are so many chemical processes are there. In that, just I am saying one here, that is a thin p-type semiconductor wafer is taken and they add small quantity of pentavalent impurity to that. Then part of that wafer, it will be converted into n-silicon wafer. Then there is a junction formed. There are several processes by which a semiconductor can be formed. The wafer now contains P region and N region and a metallurgical junction between P and N regions. Okay. Now, what happens here? The most important two things we have to learn from here is diffusion and drift. Two important processes occur during the formation of a PN junction, diffusion and drift. So, we should be very careful to learn those things because they are very important. We know that an n-type semiconductor, the concentration of electrons is more. So, all of you know n-type, N stands for negative. Negative means electrons are the majority carriers and holes are the minority carriers. So, now here in an n-type semiconductor, the concentration of electrons, that is number of electrons per unit volume is more compared to the concentration of holes. Similarly, in a p-type semiconductor, the concentration of holes is more than the concentration of electrons. P stands for positive. Generally, holes are representative of positive. Therefore, in P, majority carriers are holes and minority carriers are electrons. During the formation of PN junction and due to the concentration gradient across P and N sides, holes diffuse from P side to N side and electrons diffuse from N side to P side. This motion of charge carriers gives rise to diffusion current across the junction. So, what is happening here? So, if you think this as a PN junction, here P type and here N type. In N we have lot of electrons are there and majority carriers, and in P type we have lots of holes are there. When a junction is formed, holes diffuse from this side to this side and electrons diffuse from this side to this side. So what will happen now? Now after they diffuse, for some time both of the majority charge carriers, they cross the junction, that gives rise to diffusion current. When an electron diffuses from N to P, it leaves behind an ionized donor on N side. What happens? Electrons, once they come from N to P, that ion will become a positive ion. Here you will get one positive ion for every electron leaving the junction. Once one electron leaves one atom, you know that it becomes a positive ion. Similarly, once one hole comes from this side to this side, this electron goes and joins with another atom there. That side, negative ions are created. So, at the junction, if you see here, what will happen at the junction? In the N type, you have lots of positive ions, and in the P type, you have lots of negative ions are formed. Now it is continued like that. Okay, as the electrons continue to diffuse from N to P, a layer of positive charge or positive space charge region on N side of the junction is developed. Okay, So let's continue our discussion. I'll clear this page and go to the next page to explain that. It's a very important topic, children. So you need to learn with maximum care. Okay. So now let's go to the next one. Now let's see. Similarly, when a hole diffuses from P to N, as I told you earlier, due to the concentration gradient, it leaves behind an ionized acceptor, that is negative charge, which is immobile. As the holes continue to diffuse, a layer of negative charge or negative space charge region on the p side of the junction is developed. This space charge region on either side of the junction together is known as depletion layer. This is the important term we need to know. That is the depletion layer. As the electrons and holes taking part in the initial movement across the junction depleted the region of its free charges. So it is shown in the figure. I'll just take you to the figure. So this is the figure you can see here. Now here clearly you can see here, from N side, when an electron comes this side, positive ions are created on the N side, and when holes come from this side to this side, negative ions are created near the junction. So this thick layer which is formed here, this is called as depletion layer. This is called as the depletion layer. So that is what I told you. I'll take you back to the previous slide again. Now, if you see, the thickness of depletion region is of the order of 1/10 of a micrometer. You know, micrometer is 10 to the power of minus 6 meters. So it is 1/10 of a micrometer. It's so thin. Due to the positive space charge region on N side of the junction and negative space charge region on P side of the junction, an electric field directed from positive charge towards negative charge develops. Now we all know from our first chapter, that is the static electricity, we know the electric field direction is always from positive to negative. Yes or no? So we have learnt it in our first chapter. Electric field is always from positive to negative. That is, from positive charge the arrow goes out, for the negative charge the arrow comes in. Now near the junction we have seen now a depletion layer is formed. Here already I have shown you on this is P side and this is N side. In the N side we have many positive ions are developed. In the P side we have many negative ions are developed. Therefore, there is an electric field developed and the direction of the electric field is from positive to negative. So that is what I told. Okay. So this space charge region on either side of the junction together is known as the depletion region. This is the depletion region, as already I told you, and because it is depleted, the charge carriers from that region. The thickness of that already I told you, it's 1/10 of a micrometer. Due to this positive space charge region on N side, this is the one, and negative charge region, negative space charge region on P side of the junction, that is this one, an electric field directed from positive charge towards negative charge developed. That is what I have shown here with blue color arrow. Due to this field, an electron on P side of the junction moves to N side and a hole on N side of the junction moves to P side. So because of this electric field, further there is a movement of charge carriers from one side to other side. The motion of the charge carrier due to electric field is called drift. This is the second term we are learning, very, very, very important one. Why? Because there is an electric field developed. So electron on P side, now note this point, electron on P side, very, very, very important. Earlier, holes from P side, they have crossed and they came here. Yes or no? Now electrons from P side are crossing the junction and they are coming to N side. This is the new thing what we are learning now. And after that, junction moves to the N side and holes on N side of the junction moves to P. That means here we have holes which are minority carriers. They cross the junction and they come here. Previously, what I told earlier in the diffusion, majority charge carriers cross the junction. That is, electrons from N side cross and the junction and come to P side, and the holes from P side cross the junction and come to N side. That was diffusion. Now, because of the electric field which is developed here, because of the immobile ions, minority carriers started moving from one place to the other place. That means electrons from P, they cross and come to N, and the holes from N, they cross the junction and come from N to P. That is what I am saying. So when minority carriers come, that is holes from N to P, electrons from P to N, that is called as drift. Thus drift current, which is opposite in direction to the diffusion current, starts. Now this is the thing which we need to know. Diffusion current is in one direction, whereas diffusion current is in opposite direction. Diffusion current is because of majority carriers crossing the junction, that is electrons cross from N to P and holes cross from P to N, whereas drift current is because of minority carriers crossing the junction. Minority carriers, why they cross is because of the electric field which is developed at the depletion layer because of the immobile ions. So minority carriers crossing means electrons from P side cross and come to N side, and holes from N side cross and go to P side. So what will happen now? Now you can see here this figure already I have shown you previously. So here there is an electric field. Because of that electric field, there is a potential is here which we have shown by the graph. Barrier potential means, barrier means all of you know that meaning, which stops. There is a barrier potential which is developed. What this barrier potential will do? Suppose here there is an electron, still it wants to cross the junction and come to here. So there is a potential developed here. Now you can see here all these positive ions are there. Once it comes to this side, there are negative ions. Negative ions, and electron is also a negative charged particle. They repel that and it goes back. Further crossing of majority carriers is prevented. Earlier majority carriers were crossing, now minority carriers are crossing. Now what will happen here as the diffusion process continues? The space charge regions on either side of the junction extend, thus increasing the electric field strength and hence drift current. This process continues until the diffusion current equals the drift current. So earlier diffusion current was more, now drift current is increasing. After some time both of them are equal. Thus PN junction is formed. In a PN junction under equilibrium, there is no net current. This is another important point to be noted. Whenever I say an important point, that is useful for MCQs or it is useful for some assertion reason questions. Take care of that. Now the loss of electrons from N region and the gain of electron by the P region causes a difference of potential across the junction of the two regions. So there is a potential difference developed, which already I told you. The polarity of this potential is such as to oppose further flow of carriers so that a condition of equilibrium exists. That is figure 1411 shows the PN junction at equilibrium and the potential across the junction. Okay. Already I told you. Further diffusion is stopped because of this electric field which is developed because of the barrier potential. The N material has lost electrons and P material has acquired electrons. The N material is thus positive relative to the P material. Since this potential tends to prevent the movement of electron from N region into the P region, it is often called a barrier potential, as already I told you. So once again I tell, if an electron wants to cross and come this side, this is repelled by the negative ions and it goes back. Further crossing the junction is prevented. Okay. Now this is all about the PN junction formation. Thank you for watching. God bless you all and grant you all great success in the coming exams.